Motorola is bleeding money. Defects are costing them millions every month. Customers walking away. Bankruptcy is a real world possibility. Then, one frustrated engineer asks a question that may change everything. His name is Bill Smith, and his answer will not only save Motorola, it will go to revolutionize the world and how we think about quality. This is the story of Six Sigma.
Welcome to Advanced Quality Programs with Juan Navarro. In this podcast, we're going to dive deep into the world of quality and leadership philosophies that drive successful businesses and great leaders to actually apply them to your everyday life. So if you're ready to improve your life, one quality principle at a time, let's get started.
Every manufacturer faces the same nightmare. You inspect for quality, you catch defects, you fix them, but you can never predict where the next problem is going to come from. And this is reactive, expensive, and exhausting. Bill Smith at Motorola realized something critical that has been known since Deming cycles were introduced to Western industry. Reactive quality control kills efficiency. It was killing American competitiveness and, in a sense, continues to do so. Japanese manufacturing were outpacing them, not just because they were able to catch defects, but because they prevent them from happening in the first place. Smith needed a way to predict and prevent defects before they were happening. But how do you measure something that has not occurred yet? Smith borrowed a concept from statistics. Imagine throwing darts at a bull eye. Most cluster around the center, but some scatter wide. That scatter, statisticians call it Six Sigma, or they call it Sigma, that Greek letter that we use to represent the standard deviation, the probability of missing the target. And here's Smith's radical idea. He asked, what if we could reduce that scatter so dramatically that only about 3 out of those darts, out of every million that we throw, miss the bullseye? That is the level of precision that can transform the manufacturing industry, and that is Six Sigma. And that name itself tells you the goal. If you know something about the statistics, it is the standard deviation from the mean, a process that yields 99.99966%. In other words, near perfection. But Smith did not just think of inventing a metric. His goal was to become the builder of a complete system to achieve that level of perfection. So look at the difference. Not achieving the goal, building the system to achieve it. And Smith, when he drafted the roadmap to achieve that goal, he thought of 5 steps, each one with specific tools or techniques that can help you to achieve that goal every time. He came up with the DMAIC process, 5 steps: define, measure, analyze, improve, and control. And with time, this became not just a theory, it became a proven process that saved not only his company, it saved many companies, billions, and let me show you how. This is the story of Align Signal. Imagine that you are a quality manager in 1995, and the company is Align Signal. Aircraft component defects are not just costing you over 50 millions annually. You are close to a crisis, and your CEO just heard Smith's Six Sigma idea. He asked you to implement that idea in the company. Where should you start? So here comes the define phase. You can't just say, my quality is bad, and just leave it like that. That's too wide, too vague. You should narrow your problem to the most important one. So you start collecting data, and after that, you can tell your CEO where the problem is coming from. What's your biggest headache? As a quality manager of Align Signal, your data show you that your hydraulic seal failures occur 2.5% of the units, costing you $840 7 per failure and impacting customer satisfaction scores by 12 points. Yeah. Now, notice that precision from quality is bad to specifically telling you the part, the percent, the cost, and the customer satisfaction. That's the idea of define, to have a clear problem statement with measurable goals, a defined scope. Now you can start measuring. That's the measuring phase. And you cannot improve what you cannot measure, as many listeners from the podcast might recall. So in your new quest, you ask your team to collect failure data for, let's say, 15 days. Where do seals fail? Which production lines? What conditions? These are questions that will address the defined problem, and you need to collect data on that questions. So you use your control charts to establish baseline performance. After collecting data several days, you can calculate the current sigma level. In other words, how far away from the target you are. And by checking your measurements, you identify parts of your process that are wrong. These are the critical to quality characteristics. Now, that data becomes your foundation. And it shows you or brings you to the analyze phase. Here and now, you become a detective. Why are these ceilings failing? Why? Your team brainstorms. You create fishbone diagrams. You map potential causes along the process, material quality, operator technique, equipment calibration, environmental factors. You test all your hypotheses using data and statistical analysis. If you are a statistician, an engineer, you use regression analysis, analysis of variance. If you are not a statistician, you just look at the data and you will find a hint where is the problem. The idea comes up. Temperature variations during the curing process. Let's stay there. Let's say 15-degree fluctuation is causing molecular bonding failures. Some of your engineers will say that after looking at your charts, they had that as your root cause identified. So the question now is how you improve. Improve that phase. With that experience, it is not guessing anymore. You can proceed with systematic testing. Your team uses experiments to test your idea. Different curing temperatures, durations, humidity levels. You run controlled trials and measure results. The fun part is like playing Lego for grown-ups. And after that, the optimal combination will come up. They will come with 185 degrees, 47 minutes, 35% humidity, and wow, who knew? With that idea, you can redesign your curing process. You check the change before introducing it to the production, and then after implementing it in the production line, voila, defects had dropped not only a little bit, 73% from the first week. Your controlling department starts validating your solution. What happens now? This is the control phase. This is where most improvement initiatives fail. Because now that you have the foundation, the excitement starts fading out. Old habits will return, but the good thing is it is not happening with Six Sigma. You create control plans, document your findings, establish monitoring systems, and you start training your operators on the new process. You document your standard operating system, and you transfer the ownership from the improvement team to the production team. And the result? A light signal achieved 68% defect reduction. It means 1.2 billion over the first 4 years. And that is the power of the mic, the power of Six Sigma in action. Now, let's have a review, a quick quiz. If a process operates at a 4 Sigma level, how many defects per million of opportunities you have? For every million babies that come to the world, how many survive? The answer is 6,210 defects per million, or babies. Six Sigma is 3.4 defects 1,800 times improvement. That is the difference between losing customers and dominating your market. And the belt system, where it comes from? Six Sigma borrowed something cool from martial arts, that belt system. White belts, yellow belts, learn the basics. It's awareness training. They understand the methodology, but they are not able to lead the projects. Green belts can manage smaller projects while doing their regular job. Think weekend barriers tackling quality issues part-time. Black belts are full-time quality professionals. They lead major initiatives, mentor green belts, and drive organizational change. Master black belts, they are senseis, training, coaching, guiding strategy across the entire organization. And the champion sits at the top. These are the operational leaders who sponsor projects, remove barriers, and this structure ensures Six Sigma to become embedded in the company culture, not just one-time initiative. Let me put that numbers in perspective. That 1.2 billion Allied signals saved, that meant job security for 50,000 employees and safer aircraft for millions of passengers. Not only that 1,800 million improvement of flights each year, that should be multiplied by the times every plane has for millions of passengers. That's a lifetime of a company. Motorola, 20% annual profit increase. That transformed them from the bankruptcy risk to industry leader. Their stock price tripled. ASEA Brownberry, 68% defect dropped after adopting these practices. And yes, those guys with the orange robots. That meant fewer customer complaints, less rework stress for workers, and 30% lower production costs passed to the customers. Six Sigma delivers hard financial results and soft cultural benefits, aligned with customer expectations, sustainable improvement mechanisms, and analytical skills for your employees. Better quality, lower cost, happier customers. Here's what Six Sigma teaches us. Quality is not just luck, it's a discipline. Whether you are managing a factory floor, a service team, the DeepMic framework gives you a proven roadmap from problem to solution. Start small this week, pick one recurring issue, define it precisely. What exactly is the problem? How much does it cost? Measure your performance, collect data from at least 2 weeks, find the root cause, use diagrams like Fishbone, the 5 whys, test your solution, run a small pilot, and log the improvement, document it, train your team. That's Six Sigma in action. That's all for this week. If you want to dive deeper into the specific tools and techniques, check my books, The Quality Principles, Life Quality Projects, or go further learning to enhance your thinking with my book, The Quality Mindset. And if this helped you, subscribe for more practical quality measurement strategies every week. This is Juan Navarro. Stay agile, stay excellent, and make things better.
One small change triggers everything. Watch how agile thinking works. Inspect, adapt, repeat. Each step builds the next, creating confident, unstoppable momentum. This is the Quality Mindset by Juan Navarro. Get your copy now.